this series is about the operations on sets. So these are the different operations that we do on sets. In this video, we are going to learn about intersection of sets. Let's first see what is intersection. So intersection of two sets A and B is a set which consists of the common elements. So the word common is important here. The elements which are common to A and B both, the elements belonging to both the set at the same time. So that is the intersection. It is denoted by this sign. This is the sign of intersection. So if we have two sets A and B and we are to find out the intersection, so it's going to be A intersection B. Now let's try to understand with the help of problems. Okay, so we have four kinds of problem in this as well, depending upon the categories of set. So the case one is, or set one is the overlapping sets. So here is our problem. These are the two sets, set A which is 1 2 3 and set B is 3 4 5. These are overlapping sets because 3 is common in both. A has some elements which are not in B and B has elements which are not in A. So there is some elements common or overlapping. So therefore these are overlapping sets. Now how to do the intersection of such kind of sets. So first let's write A intersection B. 1 2 3 intersection 3 4 5. You can do it directly as well. So intersection, as I told you, is the operation in which we are only dealing with the common elements in both. So here the common element is 3, so A intersection B is going to be 3 only. Let's make our Venn diagram. So we have A set and we have B set. This is A and this is B. This part which is in the middle, this is the overlapping part, or it contains, this section is shared by both. So we have 3 which is shared by both. On the side of A we have 1 and 2, and on side of B we are left with 4 and 5. Here in intersection we only shade the part which is overlapping. So here only this part would be shaded. So this shading shows the intersection. So A intersection B. The second case is that of the disjoint sets. So disjoint sets are those sets in which we don't have anything in common. So A has ABC and B is XYZ, so there's nothing common. So how we would do the intersection? So A intersection B, since we don't have anything in common, so the answer is going to be the empty set or the null set, since there is nothing common. So how we are going to represent it in pictorial form? The Venn diagram would look something like A, B, C. This is set A, this is set B, which is X, Y, Z, and there would be no shading because there's nothing common. So this is A intersection B. Now let's see the third case, which is the case of the equal sets. So when we have equal sets here, so you can see the number of elements is also same and the elements themselves are same. So A intersection B is 1 2 3 intersection 1 2 3. So all the elements are same in both the sets. So 1 2 3. So this is how we do intersection of the equal sets. Case number 4 is when one set is a subset of another. So here you can see that A is a subset of B because all the elements of A are in B. So let's work out for it. 2 3 4, 1 2 3 4 5 6. So let's first highlight. So we have 2 we have 3, and we have 4. So all the elements of A are in B, so it's a subset of B. So they are not overlapping because all the elements of A are in B, right? So since intersection contains only the common elements in both, so 2, 3, 4, it's going to be the A intersection B. Let's draw the Venn diagram. So we have, this is our superset basically, superset, and this is our subset. So let's draw the superset. So this is the superset. The smaller one is the subset. So this is A, the outer one is B, and we have 2, 3, 4, which is in A and B both, but B has elements 5 and 6 which are uncommon. So here the highlighted area would be A. This would be shaded because this is the intersection part, the part which is common in both. So this was all about intersection. Let's do some practice. Okay, so now it's practice time. So we have a problem here. We have A equals to 1, 2, 3, 4, 5, 6, and B equals to 2, 4, 6, 8, 10. So now let's do the intersection. So A intersection B is going to be the common elements. So we can do it directly as well, but let me do it in conventional way. So this is how you write intersection 2, 4, 6, 8, 10. And now let's see for the common elements. The common elements are 2. These are overlapping sets because all the elements are not common. 4, and we have 6 in common. 2, 4, 6. So A, B, this is set A, this is set B. We have 2, 4, 6 in common, and here on this side we have 1, 3, 5, and on this side we have 8 and 10. And let's shade the middle part, which is the intersection part. So in intersection only the common part is shaded. So this is the Venn diagram. Now let's try this problem. So here A intersection B is equals to A B C intersection A B C D E. Now let's mark the common elements A B C A B C. So all the elements of A are in B, so it's a proper subset. Let's draw the Venn diagram. So we have a superset, which is B, which is a bigger set, and in that we have A B C A B C. This is set A inside, and the outside circles that of B, and B has elements D E, which is not in A, so we'll write here. And let's shade this A. So this is A intersection B. Let's try this one. So A intersection B equals to 1, 3, 5, 7, 9. Intersection B is 2, 4, 6, 8, and we don't have anything in common, so it's an empty set. A intersection B. So you can draw the Venn diagram as A and B, and since they don't have anything in common, so 2, 4, 6, 9, 6, 8, nothing would be colored in this. So I hope that it's easier now. Have a happy learning. Don't forget to like, share, and subscribe to the channel for more such videos.